So what we're going to do here is look at matrix A is 2, 3, 4, 7, and B is 0, 1, 5, 6, where we're going to compute matrix A times B. So we're going to go with this as we saw in that last bit there, with those row by column ideas. We're going to go through this carefully, step by step. So first you got AB is just AB, and for this, because of how these things get combined together, we've got some nice-ish color coding for the rows of A and the columns of B so that we know what's going to go where. And when we multiply these out, what we're going to end up with in the first cell is something that combines row 1 of A with column 1 of B. Then in slot 1, 2, we're going to get something that uses row 1 of A and column 2 of B. Then for 2, 1, we're thinking in terms of row 2 of A and column 1 of B. 2, 1 goes to 2, 1. And then finally, for slot 2, 2, we have row 2 of A and row 2 of B. 2, 2 comes from 2, 2. And then how we stick them together is in terms of those combinations, where for 1 times 1, in a sense, it's not really 1 times 1, we have the slot 1, 1 in each being multiplied, so 2 times 0, plus the slot 1, 2 multiplied by 2, 1, which here is 3 times 5, while for the 1 times 2, we're going to take the 2 in slot 1, 1 of A and multiply it by the 1 in slot 1, 2 of B, plus the 3 in 1, 2 times the 6 in 2, 2. So for the first row, for now, before we add things up, we will have 2, 0 plus 3, 5, and 2, 1 plus 3, 6. And then in the second row, it's very much the same idea, just with different numbers. So for the 2, 1 combination, we're going to have 4 from slot 2, 1 of matrix A times 0 from the 1, 1 slot of matrix B plus 7 in 2, 2 times 5 in 2, 1. While for our slot 2, 2, matrix position 2, 2 will come from row 2 of A and column 2 of B. So we'll have 4 times 1 plus 7 times 6. And I put those in that order for consistency. Usually we like to write things left to right for a reason that I'll talk about in a minute. But long and short of it is, once you have all 4 of these pieces, all 4 of these combinations that follow that specific pattern, what you'll end up with is the matrix 15, 20, 35, 46. And in general, we're not going to look at this just yet, but I'll give a hint for what we're going to see in the next piece. When we talk about multiplying a matrix with m rows and n columns by some other matrix with n rows and, say, p columns, in a way, that middle kind of squeezes out. And what we end up with is a matrix that has m rows and p columns. But we'll see what that looks like next.